Hi, I'm Paul Glazer, and today I'm going to be sharing with you updates about new and upcoming features in Simio. Before we dive in, I want to give a quick introduction. I'm the Vice President of Consulting Services here at Simio, and I lead a team of engineers who help customers turn Simio models into scalable decision tools. I've been building simulation models for over 10 years, both as a consultant and as a business user. My background is in operations and supply chain. I've worked across a number of industries, including chemical, automotive, and insurance. In those roles, I've covered everything from engineering to strategic planning. And a fun fact about me is I actually started my journey as a Simio customer. I've evaluated several platforms, and I chose Simio over some of our well-known competitors. I want to frame the rest of this update conversation with a broader mindset shift, which is Simio is evolving from a simulation tool into a scalable solution platform. Let's break down what that means. Traditionally, most of us have used Simio through the desktop application. This is a powerful IDE where modelers design, build, and test simulation models and digital twins. It's the creative workspace where flexible, reusable logic is developed and to solve real operational challenges. Then there's Simio Portal, our cloud or on-prem web client. This is where models get published and become usable by business users. The key here is control. Portal exposes only the necessary inputs and actions so users can run plans and adjust parameters and explore what-if scenarios without touching the model logic itself. With these two pieces, desktop and portal, we're now in a new paradigm. The models we build aren't just files anymore. They're digital products. Modelers aren't just analysts. They're solution developers. And Simio becomes a platform that enables teams to deploy intelligent, simulation-powered business applications. This shift matters because expectations are rising. Business users want scalable, integrated tools that empower decision-making and collaboration across teams. That's why we're evolving Simio into a true digital platform, one that supports automation, connects to enterprise systems, and transforms how simulation delivers value. This evolution is most visible in our recent updates, so let's start with version 18. Last May, we officially released Simio version 18, but as many of you know, there have been several insider releases and updates since then. It's worth recapping the major highlights so that everyone knows what's new in the latest versions of software. Version 18 introduced Next Generation Simio Portal, or NextGen as we call it. It features a fully redesigned user interface, major API improvements, and overall modernization of the system to support better usability, performance, and scalability. On the data side, we rolled out new integration features that make it easier to connect with external systems and manage large-scale inputs and outputs more effectively. We also spent a significant amount of time both with our internal teams and customers listening to feedback, and as a result, we've made major improvements in our debugging tools, making it faster to trace issues, validate logic, and get to the root of problems. And finally, we introduced expanded support for material storage applications, laying the groundwork for more sophisticated warehouse inventory and logistics modeling. All this sets the stage for big advancements that we're going to introduce in version 19 later in this presentation. But first, let's dig into Portal itself, what it is and why it matters. Simio Portal is our browser-based application. It's hosted on a central server and can be deployed on-premise or in the cloud. We've implemented it in a wide variety of environments, everything from secure air-gapped networks for the government clients to AWS, Azure, and even local shop floor hardware. That flexibility makes it easy to fit into whatever network architecture your organization already uses. The big benefit, Simio Portal gives users a seamless access to models and results without needing to install the Simio software. It's the easiest way to share simulations with colleagues who may not have Simio on their machine or any simulation experience at all. Portal supports enterprise-carried features like single sign-on. That means users log in with their corporate credentials and access is managed through your existing identity systems. It's secure, streamlined, and familiar. And because Simio Portal runs on a scalable cloud infrastructure, you're no longer limited to 4 or 6 cores on your laptop. You can deploy it with load balancing and scale to tens or even hundreds of processors and allow multiple users to run complex experiments in parallel. Let's start with the user interface, because if you've used our older version, you'll notice right away the experience is completely different. We've rolled out a modern, redesigned interface that aligns with what users expect from today's web platforms. It's cleaner, more responsive, and easier to navigate for both modelers and business users. The look and feel are just the beginning. Under the hood, Simio Portal now runs a more efficient architecture, which means faster load times, smoother navigation, and better responsiveness, especially when multiple users are working at the same time. You'll also notice a job queue on the left-hand side. This is a major improvement for collaboration. If you're running several experiments or sharing models across teams, the queue shows exactly what's in progress, what's pending, and what the status is of each run. It gives you clearer visibility into the system activity in real time. We've also added better status indicators as well, so you'll get immediate feedback on model runs, experiment states, or any errors. That makes it much easier to monitor and troubleshoot at a glance. These updates are all about usability, performance, and helping teams move faster. In addition to the UI improvements, we've made some major upgrades to the REST API as well. For those of you who have worked with our API before, this will feel familiar, but far more capable. For those of you who are new to it, think of the API as a bridge between Simio and any external system, whether it's Python, a custom app, or a machine learning pipeline. We now include a built-in Swagger page directly in Simio Portal. This is a web-based interface that makes it easy to explore, test, and understand API calls. It's especially helpful if you're new to APIs or you just want to prototype quickly. The process is simple. First, log into Portal and grab your personal access token. Use that token to generate a bearer token. Then you'll be able to make authenticated API calls across models, run simulations, retrieve results, and more. You'll see on the left-hand side of the Swagger UI calls to get models, start runs, pull experiments, etc. These are the building blocks of full automation. What this unlocks is the ability to create complete script-driven workflows in Python. You can generate results, monitor status, extract data, perform analytics, do all the things without ever clicking through the interface. This is a huge win for planners, schedulers, and anyone wanting to do machine learning, automation, or optimization. The new API puts all of that within reach. Now let's turn to the data side, because version 18 introduces several features that make working with model data faster, clearer, and more connected. First up is something our users have requested for a long time: table referencing from submodels. Now, top-level models can directly access data and output tables defined inside of submodels. That means less duplication, less manual data shuffling, better visibility across your model hierarchy. Second is a new table schema viewer. As models grow more complex, understanding how your tables relate becomes critical. The schema viewer gives you a clearer visual map of your table relationships. It's a huge help for modelers, especially those newer to the data side, who want to simplify, audit, or refine how their data tables are connected. You'll start to see more horizontal table relationships and a clearer picture of how your model's data is structured. It's a smart way to identify opportunities to streamline. And finally, something I'm especially excited about is expanded cloud data integrations. In version 18, you'll see two new importer-exporter options, Amazon S3 and Azure Blob Storage. These open up new possibilities for lightweight, scalable data exchanges. Why does this matter? Because blob storage is fast, cheap, and accessible by API. You can import and export JSON and CSV files easily, automate workflows, and use it for temporary data sets that you don't need to live in full-scale databases. We're already seeing users generate simulation input files, push them into the S3 or Blob, and run multiple portal simulations off that data, and clean it all up afterwards. It's efficient, affordable, and a great fit for simulation workloads. And now I want to share with you some of our other enhancements that'll help you debug and work through models faster. If you spent time tracing process logic in Simio, you know how quickly things can get complex. That's why we've added several tools to help you get to the root cause faster. First, you can right-click on a trace row and jump directly to the corresponding step in process logic. No more hunting around to figure out when something happened. The trace takes you straight to the source. Second, we've added more granular control over trace levels. You can now enable or disable tracing both at the process and the step level. That means you can now zero in on just the logic you're troubleshooting without being buried in all the noise from the rest of the model. This is especially helpful if you're working on large, complex traces. You can narrow that scope, focus only on the relevant steps, and it will make the whole debugging process much more efficient. Finally, you can disable tracing for specific steps entirely, which is helpful if you want to keep your logs clean, or if you're creating trace outputs for other users and want to highlight only certain parts of the process. These tools are all about precision and speed, so you can find issues faster, collaborate effectively, and get to value sooner. There are a few more great additions on the debugging side. These are especially helpful for day-to-day model development. You can now right-click on any process and add it to the watch window. This gives you real-time visibility into what's happening inside that process as the model runs. If you haven't tried it yet, give it a shot. It's a really useful way to debug logic live without digging through layers of trace output. On the error handling side, we've made things smarter. Error messages now highlight exactly which part of the expression is causing the failure. So instead of just saying the expression failed, Simio will underline and highlight that part that actually is broken. It provides better parsing and visibility and should cut down on the time that's spent tracking down syntax issues. And lastly, a small but powerful change. You can now double-click on an error in the error window, and it will take you straight to the corresponding table row. This is a huge time saver when debugging table-driven logic and working on larger data sets. All of these changes are designed to help you get to the problem faster, fix it with less effort, and ultimately deliver better models in less time. If you've ever worked with a large data set in Simio, you've probably struggled to track down specific rows or identify errors buried deep in your data set. We've added several new features to help make that process easier. First, you can now double-click on an error in the error window and go directly to the table row that triggered it. No more scanning row by row. You go straight to the source and can troubleshoot immediately. We've also introduced targeted row navigation. You can now jump to a specific row in the table. If you're debugging a scenario and want to know the row number, just a couple of clicks to get there. Another big one is you can filter a table to only show the rows with errors. It's a huge time saver when you're importing large data sets. You bring in thousands of rows and just 2 fail. You can now isolate and resolve those problems in seconds by filtering down to rows with errors. We've also added row counts in both tables and logs so you can quickly verify that all of your data imported as expected. It's a small change, but it helps with quick validation and sanity checks. And finally, we've made it easier to clear filters with a single click. As you work through your data, this makes it much faster to toggle between filtered and full table views. These updates are, again, about giving you better control and visibility when you're working with data, helping you resolve issues faster. And to wrap up feature updates, here are a few small but powerful additions to make day-to-day modeling faster and smoother. First, you can now copy, paste, and delete multiple consecutive steps in your model's process logic. If you've ever had to refactor a model, sync logic between models, or move code from one process to another, you know how tedious it can be. Now you can grab a block of steps, copy them once, and paste them wherever you need. Fewer clicks and less rework. Second, you can right-click on a foreign key and instantly jump to the related primary key. It's another example of how Simio is streamlining navigation, getting you directly to the data or logic you need to investigate. And finally, we've improved the watch window by adding support for grouping elements and objects. This will make it easier to organize what you're tracking during model execution, especially when you're monitoring multiple processes, resources, or data elements in real time. These features all follow a theme: less clicking, faster navigation, and more focus on the logic that matters. Many of these are foundational changes, but now let's shift to some new modeling features. One of our most exciting features in V18 is material storage elements. Now you might be wondering, what exactly does that mean in Simio? This feature introduces a flexible, table-based framework for modeling material storage and retrieval, and it's a game changer for anyone working with warehousing, distribution, or manufacturing environments. Here's how it works. In a typical storage system, you have a structured hierarchy. At the top level, storage areas. Within those, individual storage bins. And inside those bins, you have multiple stocks, meaning different SKUs occupying the same bin, each having their own quantity. Simio now supports this full structure natively. That means no more custom process logic or entities just to simulate a basic storage behavior. The system is built in, fast, and optimized for stock lookups, movements, and consumptions. Even better, we've added selection rules that allow you to control how inventory is accessed. For example, want to pull from a bin with the lowest quantity? Prefer the one with the closest bin for travel efficiency? You can define those selection rules directly, enabling smart, rules-based inventory movements inside your simulation. This update simplifies modeling significantly and opens up a whole new level of precision for material handling and warehouse applications. So what makes this feature powerful? There are several capabilities that bring real-world accuracy into your simulation models. First, you can define capacity-constrained bins and areas. This means you can explicitly model space limitations, just like in a real warehouse. You can set how much a bin can hold, ensuring your simulation respects the physical storage constraints. Second, we support selection rules and priorities. You can implement logic like first in, first out, closest bin, zone-based selections. These mirror strategies in real warehouse operations and let you customize material flow to match your actual storage policies. You can also split inventories across multiple bins, So if you need to store or retrieve partial quantities from different locations, that's now built in. And finally, you can animate these material storage elements. This is especially useful for validation or when presenting the model to stakeholders. You'll see bins visually reflect the storage levels, stacking up or drawing down in real time, giving clear visual feedback on how the material is being used across your system. It's a major enhancement for anyone who's working in the material handling, logistics, or inventory management. Let's walk through how this powers a smart warehouse model. We're seeing a growing demand for smarter, more adaptive warehouse operations, whether it's integrating automation like AGVs, rezoning storage areas, or testing new picking strategies. The good news is Simio supports all of that logic natively now. You can bring in table-based data from your existing warehouse systems, current inventory, shelving configurations, bin definitions, and more. The material storage element aligns with the data structure used by most ERP systems. So importing and configuring your warehouse in Simio is straightforward. Once that data is in place, you can easily simulate changes like moving finished goods to a different zone, reconfiguring the bin assignment rules, or replacing manual forklifts with AGVs in targeted areas. And because the framework is now fully data-driven, these scenarios are quick to set up and easy to adjust. You can test layout changes, policy shifts, and automation investments. Evaluate them based on cost, throughput, or resource utilization. Another powerful feature is real-time inventory reservations. As an AGV or any material handler makes a pick, Simio can now reserve that quantity in the system. That reservation prevents other logic from trying to pull from the same stock, eliminating conflicts, deadlocks, and overdrawn errors. The ability to track and reserve inventory in real time mirrors what modern warehouse systems do, and now you can simulate it directly without writing custom logic. It's a big step forward in making Simio more capable, more connected, and aligned with how real-world operations work. Now, training is the key to getting value out of all these new features, so it's important to talk about Simio University. I want to highlight this resource, and I strongly encourage everyone to check it out. We've completely redesigned Simio University from the ground up, and it launched earlier this year with a focus on faster onboarding, more relevant content, and ongoing support. One of the biggest changes is a condensed quick start path. If you're brand new to Simio, or if today's the first time you're really digging in, we now offer a one-day fundamentals course designed to get you up and running fast. All the key concepts are distilled into streamlined format so you can build confidence momentum in just a few hours. Second, Simio University now supports a choose-your-own-path model. You'll find more standalone modular lessons that allow you to focus only on the parts of Simio that matter to your use case. We've heard this feedback consistently. Users want to get started as quickly as possible and dive in only to what's relevant. These updates make that possible. And finally, we've introduced Learning Bites. These are regularly scheduled bite-sized sessions where you can join live Simio experts, explore focused topics like debugging and material handling, ask questions in real time, and build your knowledge in a practical, interactive way. If something in today's session piqued your interest, whether it's the API, model logic, or something else new in V18, check out Simio University, join a Learning Bite, and get hands-on. We're really excited about the enhancements coming in version 19. I want to highlight 4 key areas. First, we're making updates to optimization performance by introducing bypass. Second, we're enhancing support for bill of materials, making it easier to model complex material flows and multi-level assemblies. But the most exciting updates are the third and fourth ones. We have a new Python integration, native, in-model, in-logic scripting that allows you to run Python directly inside of Simio. And finally, integration with NVIDIA's Omniverse, enabling powerful visualizations and digital twin interactions in a 3D collaborative environment. All of these are major steps towards flexibility, realism, and enterprise integration. Let's walk through what each one of these is going to mean to your models. First up in version 19, a major enhancement to experimentation, a new feature called bypass. PASS stands for Parallel Adaptive Survivor Selection and is designed to help you get through large-scale experiments and optimizations faster. If you've ever run a big optimization in Simio, you know exploring the full search space can take a long time, especially when you're trying to zero in on the best scenarios. Bypass helps solve that. It dynamically evaluates means and variances of your simulation outputs and identifies non-competitive scenarios early. That means the model can skip over unpromising runs and save time and compute resources. It's especially helpful when you have a large number of alternatives, if you're unsure what best is in the region, or you're preparing for a hands-off method like KN or OptQuest for fine-tuning. Even better, bypass is interactive and flexible. You can pause the experiment and evaluate how tight the results are getting. You can add more scenarios and resume without losing your progress. Think of it as like a macro level filter, a way to focus your search space before committing to more intensive optimization. For users with limited time or compute capacity, this is a powerful new way to make experimentation smarter and more efficient. Production logic is also going to get an upgrade here, so let's talk about bills of material. Simio has supported bills of material for quite some time, but we've recognized that the existing feature set wasn't meeting the growing needs of our real-world production supply chain scenarios. So we've rebuilt it from the ground up. The new bill of material framework is fully table-driven and tightly integrated with the material element. You'll see it clearly organized in the Simio menu under BOM groups and BOMs and BOM components. This new structure makes it far easier to represent complex and realistic production logic. One of the major upgrades is native support for multiple bills of materials. You can now model alternative BOMs for the same product. You can define component-level substitutions, where one material can stand in for another if inventory is limited or depleted. This is a huge win for both scheduling and supply chain planning, especially in environments where flexibility and material availability impact execution. With this new framework, Simio can now dynamically look across available inventory, match against valid BOMs for a given time window, apply prioritization rules, and then automatically select the best or only available bill of material during runtime. Even better, the new BOM system is fully integrated with Simio's reserve, consume, and produce steps. That means material movements can follow the updated BOM structure without needing custom logic. This is a significant leap forward in how Simio supports real production planning and adaptable manufacturing workflows. So what makes this BOM structure so powerful? It's not that you can just define multiple bills of materials per product. You can also embed rules, constraints, and timing that mirror real-world planning logic. For example, you can set validity windows, just like you have in your ERP. If a BOM is only valid for a particular date range, Simio will automatically apply it at the right time. You can define prioritization rules, telling Simio which BOM you prefer when multiples are valid. You can even model material mixing. If a recipe allows substitution or blending between two components, Simio can handle that. Or if you want to enforce a strict one or the other approach, that's supported as well. This is especially valuable for phased production rollouts. If you have a change to recipes over time, say in 3 or 6 months, Simio will read the bill of material validity dates and apply the correct logic for that period. This turns your simulation into a fully dynamic environment that reflects real-world constraints, sourcing logic, and changeovers. One of the biggest updates in Simio version 19 is this. You can now run Python directly inside of your Simio model. Simio now supports native Python steps, which means you can execute custom Python logic as part of your process logic using a new scripted step type. Here's how it works. You create a Python step inside of your Simio process logic. You can pass data into the script from state variables, model tables, or input parameters. That data is passed into the Python data frame or whatever you have in your script, and that logic runs a calculation, an algorithm, an API call. The Python step then returns data back to Simio, and your model can immediately use the results. This is a game changer for teams that already use Python in other parts of their business, whether it's for forecasting models, data science, or third-party APIs. Instead of trying to rewrite that logic inside of Simio, you can now bring it in as is. It is also incredibly useful for complex calculations, advanced math, or any other scenario where specialized Python packages will save you time. I'm going to hand this off to Jeff now to give us a quick preview of how this feature works in Simio.
Thanks, Paul. So the use case here is to demonstrate how to use the Python script step in a Simio model. And so I have this simple model where an arriving entity chooses the shorter of the two queues, either server 1 or server 2, or uses a preferred server in the case of ties. And so I would typically implement this using the built-in logic of the output node, but in this case, I want to use the Python step instead. So if you look at the source, I have this add-on process, and the add-on process uses this choose server Python script step to implement that logic. And so if you look at the definitions, there is a new section called scripted steps, and I have a scripted step called choose server, and I pass the information in this case, the two queue lengths and the preferred server, along with the return value, token return value. And when this process executes, the Python, let me pull that up here, the Python is executed. So in this case, here's the code for that choose server script step. You can see I read the information in. I then print some information to the trace. I read the queue lengths, and here's where I'm making the decision about which server to use and then passing that information back through the token return value. And so if I run this model and then look at the trace, stop the model, and then look for my trace step, there they are. And so go back to the process. The blue is the notify and the orange is the result of the script step. And so in this case, you can see that the two queue lengths were equal, 3 and 3. And so the return value was Q2 because that is the past information about the preferred server. So again, this is a very simple use case where I just pass a couple of pieces of information in and then implement the decision logic and pass that decision back. But it demonstrates the capability of being able to provide information from the current state of the model to the Python step, and then implementing arbitrarily complex logic in the Python step, and then returning that information back to the model, in this case in the process, in its current state.
All right, thanks, Jeff. Exciting stuff. And finally, we're excited to share something that's still on the leading edge, but incredibly promising. A real-time integration between Simio and NVIDIA Omniverse. In collaboration with NVIDIA and several of our enterprise customers, we're introducing the ability to create a live digital link between your Simio model and the Omniverse visualization environment. If you're not familiar with Omniverse, it's NVIDIA's platform for building immersive, high-fidelity 3D environments. Think Pixar-level animation quality rendered in real time. Behind the scenes, Omniverse runs a powerful file format called USD, Universal Screen Description. At the core of this integration is the Nucleus server, which manages and serves up those USD scenes. Here's how Simio connects. Using new process steps, Simio can send live updates to the Nucleus server, driving animations like object movement, creation, and destruction. It also works bidirectionally. Simio can receive inputs from the Omniverse, allowing visual interactions or external triggers to influence simulation behavior. This opens the door to high-fidelity, real-time digital twin experiences. Imagine using Omniverse to visually monitor your system and seeing it react with your Simio logic, whether that's equipment movements, material flow, or operator activity. And now here's where it gets even more interesting. With Simio Omniverse integrations, you're not just getting high-quality visuals, you're also enabling live interactions with simulation parameters. For example, a user could adjust the forklift speed in real time. The visualization would respond instantly, reflecting an updated simulation behavior. That means you're not just observing in the Omniverse, you're interacting. This level of visual fidelity is especially valuable for use cases where stakeholder communication or operational validation is critical. On the right, you can see how Omniverse allows for near photorealistic environments, bringing your digital twin to life in a way that's intuitive and immersive. But beyond visuals, there's something even more forward-looking here. Because Omniverse is built on the USD platform, Simio can now interact with these scenes and objects in a structured, programmatic way. This structured interaction is crucial in a world where AI agents are starting to coexist in these environments. Now imagine this. Simio is directing AMRs around a warehouse. Meanwhile, an AI agent, either an Omniverse or external, observes certain zones that are always congested. That agent could feed information back, either through Nucleus server or directly to Simio, triggering new logic or adjustments to AMR routing behavior. This creates a closed feedback loop where simulation, visualization, and AI, a shared environment where Simio drives the logic and other systems, even intelligent ones, can react, learn, and influence. It's a huge step towards collaborative AI-aware digital twins, and we think we're just getting started. Let me show you a quick example of how this works in action. On the left-hand side of the screen, you're looking at the USD Composer. This is Omniverse's real-time viewport showing the digital scene. On the right, we have Simio running a basic model. Inside the Omniverse, you'll see the USD structure. Every object in the scene is listed, and Simio is going to map directly to that scene. So we're going to take that same forklift object, create an entity in Simio, and move it through model logic. Now watch what happens when we hit play in Simio. You'll see the forklift appear and start to move in the Omniverse. They're perfectly synchronized. Movement, timing, state are all mirrored as well. If we press pause on the simulation in Simio, Omniverse also pauses. When we resume, Omniverse also resumes, right in sync. This tight coupling means we can now drive high-impact real-time visualizations directly from Simio, with full support of animations, interaction, and dynamic object control. This is a big step forward for simulation, presentation, validation, and collaboration. This is just the tip of the iceberg. We see tremendous potential ahead with Omniverse, and what we're launching now is only the beginning. Initially, we're focused on providing bidirectional integration and data exchange through user extensions, allowing models and USD scenes to stay in sync. As real-world use cases emerge, we'll continue to expand and improve this support. That could include deeper integrations with Simio Portal, additional automation, and smarter ways to visualize and interact with digital twins in real time. To close things out, I just want to step back and connect with the big picture. We're incredibly excited about the direction Simio is heading, and all the tools and features that we've shared today are part of this strategy. With enhancements like material storage, the new bill of materials framework, bypass for faster experimentation, all of our debugging improvements, we're focused on making simulation faster, easier, and more effective for our users. At the same time, we're expanding what's possible with Simio by integrating Python directly into models, modernizing our portal, and creating real-time connections to platforms like NVIDIA Omniverse. We're opening up powerful new frontiers for automation, visualization, and enterprise integration. We see Simio evolving into more than a modeling tool. It's becoming a decision support platform, capable of sitting at the center of your digital ecosystem. And importantly, we're making Simio more scalable. So you're not just building simulations, you're delivering digital twin products that connect real users and real systems. Thanks again for spending time with us today, and we hope you're as excited as we are about these new features.
Good morning, Paul. Thank you for that update. I'd also like to welcome Liz Millar from our products group, who's going to bring her product expertise to this conversation. So, Paul, to start off, before we get to the audience questions, you mentioned version 18, version 19, and we know that the current academic version is version 17 of Simio. Can you spend a couple of minutes to talk about how Simio's product release cycle works?
Sure. So generally, we follow kind of a twice a year release cadence. So our first release, kind of the one that we're talking about here, version 19, that's going to be the major release. That's going to occur over the summer. And then we typically also have a fall release. That one's focused more at academic users. And we may get like a partial, like a .x update that's there. I think we're trying to be more clear in some of our messaging as well around versions versus sprints. So if you think about right now, we're on V18, that might be Sprint 272 is the software you're using. But as we go into V19, it could be V19 Sprint 277. So just for users to know, that's the major version you're on, and then you can have sprints in between. So we're constantly releasing smaller updates through the year, and you'll see those as sprint numbers on the edition there. I think this will become a little bit more clear when we have the My Account set up in the customer portal. So Liz, since you're here, I thought maybe you could give us a little bit of a preview of what that's going to look like for users and how that'll help explain some of this.
Sure. So we are creating kind of a new landing place for users. It's a customer portal that we call My Account. And it'll have a few different areas that users can kind of get different information from. So one of them will be a downloads page. So it has its own dedicated space where you could get our major releases, our sprint releases, also our academic releases. Everything is tagged and organized. You can kind of sort, filter, and find depending on what Simio versions you need. Other things on My Account that everyone will have access to is our knowledge base. So this is going to be a collection of articles that we are writing that cover many different topics, but basically to help users either using Simio or even just using our My Account platform or using anything in our Simio realm. So it has a lot of articles with a lot of good information that users can peruse. And then another thing that My Account does for the users is it allows them to create and manage cases. So typically, if you are kind of contacting Simio right now for any sort of support, so whether it's technical support or licensing support or academic support, you might be emailing into us. This is going to be a dedicated space where you could, submit your cases here and also manage your cases here. So you can see all of the cases you have submit. You can see our responses, our conversations with you. and it'll just be a good place to manage that. And that's the currently what's going to be available on my account. We are going to be growing and extending it to do new things in the future.
Thanks, Liz. That sounds great. Looking forward to having that roll out. One quick clarification before we go to a next question. When we talk about the academic release and public release, academic release is a public release, and so it's not a completely separate release. It's just that academic is only released once a year, and the public release is twice a year. So those will align with an academic and public release. Okay, let's see what we have for questions. Paul, there's been a lot of buzz about Omniverse integration. It's on TV everywhere. What's supported today within Simio, and what are you envisioning next?
Yeah, so right now in Simio, what we have is a set of user extensions. We like that kind of approach here as we're starting out. In talking with NVIDIA, they're still making some changes on their side and really finalizing what this platform is going to be. But just from kind of a Simio perspective, a couple of easy things you can do and jump into now. We have a data importer for USD format. So if you have a Omniverse server that's set up, you can import in a scene. So what that means is you can import the objects, some information about them, and you can start your Simio model from there. We also have some logic steps that will allow you to get attribute information, write attribute information, so you can have this bidirectional support, as well as positioning. So in that demo that I showed when we were moving around the object, we're really just passing data to the Nucleus server for new positions and orientation. So if you're familiar with the object XYZ and rotations in Simio, we just have a series of steps that will allow you to write those to the Omniverse.
Excellent. Next question. More about the Omniverse. So clarify, does it work with Portal or is it just for desktop? And any plans to change that overall strategy about desktop Portal with Omniverse?
Yeah, so in general, right? So the importers and the steps are going to work on Omniverse or Portal. The one piece that's really missing on Portal right now is the ability to run a model in real time. So if you're familiar with Portal, we've been focused a bit more on planning or experiments, which is running plans and fast forward. So we do see something down the road if the use cases are there where we could have a kind of more of a real-time mode where Omniverse and Simio are maybe running on the same cloud or the same machine. And then you could run Portal there to actually run that experiment and see the visualization through Omniverse. But a little bit of work to go there.
Okay. What's next here? So you mentioned earlier that Simio's always been designed to integrate with complex data systems. One of its strengths is its data handling and integration capabilities. Can you talk about how that is evolving with the new Python support?
Yeah, so I think with our data connectors, even going back to my time before Simio, I always appreciated the Simio data connectors. It was an easy way to get data into Simio and connect it with a wide variety of sources. Over time, we've continued to expand that. You saw earlier with V18, we've added S3 and Azure blob storage to that. I've learned a lot more about those storage elements in the last year, but one of the cool things about them is they're very low cost, and they really supported a lot of the workflows that we typically see in simulation, where maybe you just want to create a one-time data set or things like that, but you can share it among many users now. A lot of this is being held up as well by API, the REST API usage, so we support that here. I think Python's going to give us the next step. If you're familiar with our SQL or our database connections, you can run stored procedures there. And we've started to use that in workflows with our customers over the last few years to do data preparation. But those do have some limitations. So I think Python's really going to come in and fill the gap nicely. You're going to be able to use packages in Python, right? So the example I gave yesterday was around SAP connectivity, right? But there's going to be a lot of nice packages out there that enable you to connect with just a few lines of code to data sources. And then you get all the great Python libraries to transform and adjust your data. So I think that Python support is really going to open up a whole nother level. And I like the ease at which it's going to make that possible for our users, right? As modelers and simulation professionals, We're not always great on the data side, but some of these tools really simplify it and enable us to move more quickly.
Yeah, and I think any of the users out there who have experience in using Python for data manipulation are going to see this as an immediate win in terms of adding capabilities for that data integration. Next, we have back to Portal. So what does the roadmap look like for building and editing models directly in Simio Portal? Are we headed in that direction? And is Portal going to replace desktop at some point in this regard?
Yeah, good question. So I think right now, kind of going back to my framing slide for the presentation, we really see Simio Desktop being more the IDE, the place where you're going to go and you make and design and build your models there. We don't have any plans to kind of allow that same UI on Portal right now, but I do want people to think about what you can edit on models in a sense on Portal. They're very data driven, right? And so if you have a data driven model, you can actually edit that model or change the way that it behaves simply through importing different data sets. And we're starting to see that with customers, in the supply chain space of being able to create completely different supply chains just being data driven. So, on the question, I think building and editing, I don't see the UI, of dragging and dropping logic there, but I do see building and editing models in the sense of data-driven models on Portal.
Okay. Let's see, what do we have next? Can you walk us through the new bypass add-in that you mentioned? Can you walk through how it works with Scenario Generator? And so what's the typical value or what's the use case for someone running large experiments?
All right, Jeff, I'm gonna answer some of the first part of this of what I know, that I'm gonna bounce this one back to you. So I am pretty excited about Scenario Generator. Probably didn't spend enough time on that here, but if you guys have ever used OptQuest or things like that to generate and search a space, the Scenario Generator is really going to make this easy. If you know the space you want to go through and you want to do all the permutations, Scenario Generator, you can go in and say, for each of these controls, I want to do all these ranges, and you actually get the full set now. So I know that side of it. So maybe Jeff, you can speak to bypass and how those two work together.
Sure, I can talk a little bit about that. So the bypass algorithm and the bypass add-in, all of the technical details are available if that's what you're interested in. But what I want to talk about for a minute or two is just how it works and what the use case is. And so bypass is designed to quickly eliminate bad solutions. So if you think about your solution space for a large optimization model, there are plenty of regions in that solution space that are bad. And so what bypass is designed to do is to find those as quickly as possible so that you can eliminate those, letting you focus only on those that you don't know are bad. And so what that lets you do in combination with Scenario Generator, as Paul mentioned, is that you can create large sets of scenarios, knowing that bypass is then going to take those and the eliminate the bad ones, and then you can use some of our other tools like Select Best Scenario or even OptQuest with that subset of the solution space. So we're really excited about this new addition, and it's going to let us do significantly bigger experiments in terms of the number of scenarios.
And if I could jump in and add a little bit. So we're actually going to have two different new add-ins. One's just going to be bypass. So as Jeff said, that's going to be kind of eliminating the non-competitive scenarios. And then we're going to have a bypass plus Rhynot. So what that's going to do is the same thing. It's going to start with the bypass. It's going to eliminate the non-competitive scenarios. And then Rhynot's going to kind of kick in and find what would be the best scenario. So that'd be more similar to finding an optimal best solution is the bypass plus Rhynot. But just bypass on its own is just going to, again, eliminate the non-competitive scenarios so that you can kind of, as Jeff said, go to a smaller space that you might be focusing in on.
Thanks, Liz. So you've also, Paul, talked about making optimization more approachable. What are we doing? What is Simio doing to make that easier for the average modeler?
Yeah, so I think the features we just talked about, those are obviously helpful. I think in the presentation yesterday, sharing some of the Python and things you can do. If you have Portal and you have Python, there's a lot of optimization packages that are out there. And if you're coming from that side of things where maybe you're a little bit more familiar with Python and optimization, the portal API is maybe going to make this easier for you, where now you can think about building a model and kind of using your Simio skills on one hand and then your Python skills on the other. And you can run your model now through whatever optimizer package you're comfortable with. I don't know, Jeff, if you've got some ideas on kind of what's in the future or on the academic side here of, for the average modeler, what tools we have.
Sure. So we have a large suite of tools, as we've already talked about. The bypass is the new tool, and we have OpQuest, and we have select best scenario, and so on. But what we don't really have is a lot of documentation and a lot of use cases and examples that the casual user could pick up and learn from. And so one of the things that we're working on for the next 4 to 6 months is going to be to increase the amount of material that we have that helps users learn how to use those existing tools that we have. And when Liz was talking about using bypass with Rhino and things like that, it's like, let's develop some documentation and use cases where we walk you through doing that. The other big development that we're working on, we're in the early stages of creating another experimental add-on that does optimization. It does heuristic optimization similar to what OpQuest does. So we will hopefully within the next few months have an additional add-in to support that type of optimization. Let's see here. Next question. Does NVIDIA USD integration allow users with VR and not be limited to early versions of Oculus?
Yeah, that's a good question. I have not seen that exact integration out of the Omniverse yet. So what I do know about the NVIDIA offering is they really want to put a lot of their content out and have custom applications built. I know that they do have a focus on virtual reality and things like that. So I'm going to say yes, that's going to be possible in those scenes just because of who NVIDIA is. But I haven't seen it, and I can't give the full guidance there.
Okay. What do we have next? How does Simio Learning Bytes, the new component of Simio U, differ from Solutions, our webinar, our periodic webinar, and Simio Sync, which is what we are doing right now? So how does Learning Bytes differ from those two other webinar-based offerings? You want me to answer that, Paul?
I was going to say, I didn't know if you were going to ask it to yourself or to me, because I don't think I've got a good answer for you.
So Simio Learning Bytes is something that we introduced in March of this year in conjunction with our new Simio U rollout. And basically, these are very short webinars that tackle specific tech support type topics. So rather than having a general conversation like we do here, or a application or an example model scenario, which we do in Solutions, Learning Bytes are very small, typically 20 minutes with some live Q&A afterwards that tackle a very specific topic. And then we record those Learning Bytes, and then they become part of the Learning Byte catalog on Simio U, so that you can always go back and find those. They're completely searchable. So if you have a particular topic, like you want to know how to reject a vehicle request, you can go in the search and you can search for that. And if there is a Learning Byte that covers that topic, you will go directly to it. And if not, there's an opportunity for you to make a request. I want to see a Learning Byte on this particular topic. So we're really excited about introducing that and looking forward to interacting with some of our users in that environment. With the new Simio University training package, will there be any content to assist users with setting up and making use of Simio Portal?
Jeff, I'll defer here to you. I think we have added at least some new materials in Portal itself that help outline how it works. I know we've worked with at least one of our customers to help them generate some training materials for their team. So I know that content exists, but maybe you can speak to exactly where and it's at on
we do have some of that content that's been developed for specific users, and we will definitely have some more material on Simio U in that regard. I'm not exactly sure of the timeline for that, but it will be available at some point. That's all I can say about it at this point. Okay. The material storage element. Were there specific use cases or projects within Simio that led to the development of this new of the new material storage concept? And if so, can you describe them?
Sure. So yeah, I think as with a lot of things, we started to see a pattern to some of the questions and projects we were working on around material storage. And in general, I would say what pushed this into development for us was getting into very large warehouses. So if you think about uh, you know Amazon's those massive million square foot facilities, when you start to think about all of the bin locations and everything that's there, some of our some of the process logic we would build to do that started to get very slow. So we really studied that and looked at it, and knowing that it's data driven, knowing that there are systems out there, we took some time and studied that. But I think that's really the genesis of putting that in here is large warehousing operations, and we're getting a lot of questions around zone picking strategies, what types of vehicles, what types of staffing, traffic, and congestion. So, in order to support those types of things, you have to have the material storage side of that first. I won't do the technology underneath of it any justice, but the pieces that are underneath here that enable how quickly we can scan all of those bins is really impressive, right? So if you have a inventory warehouse type application, I'd urge you to explore this before you went and built something on your own to see. I think it will work well for you out of the box and enable most of the use cases here.
Perfect. And the place to start there would be with Symbits that we will definitely have for those for that new feature. Well, we'll talk about a lead-in. Will there be additional Symbits introduced for inventory management and Python integration within the model? Is there a plan to develop more complex Symbits to enhance understanding and usability? I would say this is a good question for Liz as our product team lead.
Yeah, I would say we are always trying to create new Symbits. We're definitely going to have Symbits that show some of these newer, bigger concepts. So there will be something for our material storage stuff. Hopefully, there'll be something for Python. Um, for the question about more complex Symbits, I think sometimes we even struggle with, Symbits should be kind of a smaller little one idea that we can fit concisely into a model so that people can learn this one concept. And sometimes you don't understand kind of the full power of the feature set if you can't get a larger model. So that's why we typically end up building larger examples. So we have our Symbits and then we have our examples. So some of this might come into play here. For example, I think we have heard people ask for the material storage to be a larger example so we can kind of see some of the benefits that you might want to use this for in like a larger project. So that is something we balance. And then I think some of the stuff we've already talked about today with the learning bytes kind of cover a little other portion. Maybe the Symbit covers, how to put this into a model, but then you might need a learning byte to kind of further develop, how I want to use this in my model or something like that. So I think some of our different pieces of I guess, any of our content we have need to fit together a little bit. And Jeff, I don't know if you want to speak to that anymore too.
No, I think you gave a great overview of those different cases where you have Symbits and learning bytes and example models. And I would also throw in there the solutions webinars. We can also do those on specific topics. And I think this is going to be our last question as we're coming up against the time here. With the Omniverse integration, could AR be leveraged for merging digital physical spaces for human-in-the-loop testing, for example?
Yeah, great question. So we are just getting into this in a couple of different use cases. I think this is really exciting. So the quick answer is yes, right? So basically, you can have the Nucleus server or another database that sits in between here, and you can answer a lot of really interesting questions, right? So if you're starting out in a green field and you want to know how long an operation takes, you can have the simulation provide, all the inputs to an operator at a station and outline for it. And now you have a VR headset on that's in this space, and they can see it, react to it, and then you can gather data and probably have better approximations for your day one production. So yes, I think this is going to be exciting. If I had to make a bet, I think we'll see something on this one next year.
Excellent. Yeah, that sounds like a very interesting use case. So with that, as I said, we're up against our time. So I want to thank Paul and Liz for joining here. And if we didn't get to your question, feel free to reach out to us by email, and we're happy to discuss these further. Thanks, everybody.